All right, first thing we got to do is go over the quiz.
Staple like all over. So it's just stuck together like that.
All right, this quiz was the area volume problem, which is like the easiest one of the AP exam. Again, there were like over a dozen people that got 0.
Oh, they didn't have calculators.
That is, we are in trouble. Is Brendan here? Or she asking? Kimori? Matsukawa? You sure you can even handle over there?
I can handle
Or
it.
are you going to be moved anyway?
Well, I might, but that'd be unlucky. I can take my quiz.
Nakama, did I give you yours?
Oh.
Kojima. That's why, see, this is why we have to go back to basics. Shun,
The slope of C.
Takara, Amon.
There is no C. Where
Right.
never 0 between each
Yeah, if I can find it.
That's why I
Or leave you right there.
Oh!
No phone class.
No need calculator.
Right.
You had calculator.
Oh,
Oh, nothing. Yo, you
Mechi,
I was a good
Sunada.
student about calculator.
People, if you turn around, Matsukawa, you're not gonna get another warning though. If we cannot do the area volume problem, it's pretty much all over people. So, we're gonna go over it. This is like the third area volume problem we had already. And then, Monday, your quiz is gonna be area and volume. We gotta get this. Luckily, the AP exam is not for another month. Otherwise, we'd be in deep trouble. And not only that, they actually give you the graph. 1, 2, 3, 4, 5. You got y equal natural log x. Woo! And then, what is this graph? 5 minus x. Woo! So y equal natural log x, y equal 5 minus x. And you get to use a calculator. So the very first thing that you should do is you should calculate this intersection point, because I'm pretty sure you're going to use that point for your limits of integration. Yeah? So, what are the coordinates of this point? 3.693. I will just round it off to 3 places. Now remember, when you write it on your paper, you got to show 3 decimal places now. But when you compute it, you got to use all. So you write that down, and I would store that in A. And then 1.307, I'll store that in B. And you got to show that on your paper now, because some people are not even showing it. So maybe you got to show this. This is stored into A. This is stored into B. You have to show the number that's one. In part A, this is the easiest one. Find the area of this region. Now there's 2 ways you can do it. You can do vertical rectangles or horizontal, it doesn't matter. Now if you do vertical rectangles, you're gonna have to do 2 separate integrals, because top minus bottom changes right at that point. Okay, so if you're gonna make a vertical rectangle, what is top minus bottom right here? Natural log x minus 0. Multiplied by the width, added up from 1 to
3.6.
A or B. Should I use A or B? A, because you're doing the integral in terms of x. You got to go from the x coordinate here to the x coordinate there. And then to compute this region over here, top minus bottom changes. It's 5 minus x minus 0, multiplied by the width, and you add it up from A to 5. Because some of you had some like bizarre things, like you guys were subtracting that minus that. That's not top minus bottom. I have no idea what you're doing there. Okay, so you write that down on your paper, you get 2 points, punch it in on your calculator, and you should get 2.986.
I have a question.
Yes.
Do you have to show what A and B are?
Yes. Were you here 1 minute ago?
Sorry,
You have to have the number somewhere on the paper.
Okay.
We can put on the picture though.
Yeah, as long as it's, okay, on the AP exam, this is how it works.
I don't know.
You're gonna have like 2 pages like this to do 1 problem. Sonata, you're gonna have 2 pages like this. As long as it's somewhere on one of these 2 pages, you're gonna get credit for it.
So the other one's going to be like
No, it's like, you're gonna have A, B, C, so you have at least half a page to do your work. At least half a page. Now, a lot of people did horizontal rectangles because then you only have to make one integral, because see the right minus left stays the same throughout, right, the region? Okay, however, if you're gonna do right minus left, what do you have to do? You gotta change the equations to x equals. So like this one gonna be x equal 5 minus y, and then this one would be x equal e to the y, because you gotta e both sides, right? Okay, so if you want to do horizontal rectangles, that's perfectly fine. So right minus left would be 5 minus y minus e to the y, multiplied by the width, and then you add it up from? 0. So it's going to be 0 to b in this case, right? Because you got to use the y coordinate, yes.
Isn't that part B?
No,
Oh.
no. All we're doing is find the area of this region. So you can either do it this way or that way. It doesn't matter. As long as it's correct, you get 2.986. Now, part B. Region R is the base of a solid. Now, some of you are not even reading, which is each section, cross-section perpendicular to the x-axis, that means you have to make vertical rectangles, is a square. So, if I take a slice out of that, you're gonna see a square. But again, if you're gonna make vertical rectangles, you have to make two separate integrals, because top minus bottom changes. And that's why they say over here, write an expression involving one or more integrals. It's kind of like a hint, you might have to write more than one right there, yeah? Okay, so the square, the side of the square is simply the length of the rectangle, which, okay, let's do the first one first. Top minus bottom, that's natural log x. How do you find the area of a square? You square it. Multiplied by the thickness, right, which is dx, because you made the rectangle vertically. And then you're going to add up all of these slices from 0 to a. And then, oh yeah, 1 to a. And then what about this region over here? Once you hit this point, top minus bottom changes. So now instead of ln x, it's now 5 minus x. So what would be the area of that square? 5 minus x squared, multiplied by the thickness, added up, all the slices from a to 5, and then you add them together, and you don't need to compute anything, that's it. Yes?
Does it make a difference if you put A to 0 or 0 to A? Would that make a difference for the graph since there's nothing in?
Well, you cannot go, because like your natural log 0 is undefined, your calculator is probably going to spit out an error.
Okay.
Yeah? Because, yeah.
So, on a part that's worth 3 points like this, if you get anything wrong in that equation, you get the 3 points now.
Well, you have to show that you got 2 integrals. First of all, you gotta have 2 integrals. If you don't have 2 integrals, it's a -3 already.
Really? Wait, but
Because you cannot do 1 integral, cannot. Takata.
well, you can't just take the area of the triangle and then
What triangle?
you know how it's an isosceles triangle on the right side.
Oh, you mean this thing?
Yeah.
But then the cross sections are squares now.
Oh, so
You're not
square.
finding the area. See, in this problem, you're finding the area. But in this problem, this is just the base of a 3-dimensional solid. If I slice it, all the slices are gonna be squares. So you cannot just find the area of the triangle.
You have to find each length of the rectangle.
You gotta, yeah, that's what an integral is for. You're adding up all of these infinitely thin slices to get the whole volume. All right? So basically it was 3, 3, 3. Part C now. Now come on, I thought we were good at this. No, except we're not even reading the problem. It says
Yeah.
the horizontal line.
That's tricky.
No. How can that be tricky when it says the word horizontal clear as day there?
We're just used to vertical.
Here's the horizontal line. It's going to cut it into 2 equal areas. We've done dozens of these problems already. Right? But do not solve an equation involving 1 or more integrals whose solution gives the value of k. Now, we already computed the area already in part A, so we're going to use this. So, what can I do here for part C? What do? If you make a rectangle horizontally like this, what's the length of that rectangle? Right minus left. So 5 minus y minus e to the y multiplied by the width, and I'm going to add it up from 0 to k, right? And shouldn't that equal half of the area?
Yes.
So that should equal
K
K.
And then all you have to do is, this is the area,
1.367.
so even if you found the area wrong in part A here, you can still get 3 full points over here.
Well done.
So, just take whatever answer you had here, doesn't matter if it was wrong or right, just take your answer here, 2.986, and then over 2,
Stupid.
boom, 3 points, right there.
Can you also write another
That's it.
integral?
Yes, or you could have gone, the integral from 0 to k of this is equal to the integral from, what's another one you could have written? 0 to k of right minus left dy, that is, has to equal the integral from
K to 1.307.
k to, let's just say b then, of right minus left.
Wait, you only have to put B?
Or if you like.
Yeah, if you define it on your paper, see, if you say that this is a and this is b, then from now on you can just write a and b. But it has to be written on your paper though. Because some, I forget, there are a few people that just put A, or they don't even say what A is. You have to define it on your paper. Just like, oh here, Tanner Kai right here, you know what he did? He called this one Y1 and this one Y2, so then he just put like the Y1 minus Y2 or whatever he had to do. As long as you define it on your paper, you can use it. Okay, any questions on this? Because every area of volume problem is going to be the same. That's why it's important to read.
Are there lots of these on the AP exam?
One,
Only one.
there's 6 free response questions. You're going to know 4 of them. Okay? One of them is this.
And one
Every
of them-
single year.
Wait, what about the other two?
Yeah.
What other 3? Another 3.
Yeah.
Well, that's where we're going to go over. We're going to go back to basics.
I thought you said
Particle
this-
moving on a number line. They give you the chart and you got to answer all kinds of questions. And then, what am I talking about here? Oh, the rate problem. Remember the one something about rocks were arriving at the
Oh, at the quarry.
at the quarry.
Rock processing.
Yeah, that's always there
It's
too.
okay, we have so many more weeks to continue to.
Hey, don't like. I don't want to hear that. Oh man, we got a whole month to do it. I don't need worry. I'm the man.
Well,
No, I'm saying we can improve and drill.
Definitely
I
improve.
need easy math.
Because right now, I'm not seeing improvement. Like last year, already we had like 2/3 of class. They locked up the 5 already. This year,
Me, I got
maybe
it.
2 or
Don't worry
3
about it.
are on track for a 5. But see, that can change. All you gotta do, just like Mr. Greenhill said. You guys, anybody ever had Mr. Greenhill?
Yes.
You just increase your effort by 10%, and that makes a huge difference. Just 10%. Yes.
One of the things that I'm struggling with is how we're doing different things each day instead of doing this and then learning this again the next day, but doing better.
Well, this is what we've done the past 20-something years, but apparently it's not working this year. So you know what, maybe,
Homework are not even the same as quiz.
but the last area volume problem was like this, had slices, and then area. Everyone has the same thing, you're gonna have area, slice, okay, now this one didn't have a volume where you have to revolve it around the line, but that's usually there too.
Rather have that.
But it doesn't matter, I'm gonna give, so Monday's quiz is gonna be area volume, and if need be, Tuesday's quiz is gonna be area volume too.
Oh, nice.
And then, you know what, I think we're gonna do that from now, so I'm just gonna throw away all the quizzes I printed out already.
Yeah.
And then we'll do the next one, particle moving in a number line, maybe we'll have 2 or 3 in a row of those then.
Oh, we're gonna be good.
That actually probably looks better.
Yeah.
Okay, well, whatever works, this year, we're just doing it, aren't we?
Reinforce it.
Okay, we're gonna spend just 20 minutes going over this multiple choice,
We're gonna hang out.
and then we need to go back to basics.
Thank you. I was looking forward to hanging out.
Okay, shall I read off the answers for part B to make it faster, or can you guys look over here and do it, or you want me to read it off?
Are we correcting it ourselves?
Yeah, I think it's faster, we wanna save time here. Okay, so this is part B, we already did the answers for part A. 76, B. 77, C. 78, B.
Oh.
79, B. How come I'm hearing ahs on the first 4? It's like the first 4
That's
problems.
a prank this part.
Huh? Well, I don't know, let me just read out the answers first. 80, E.
Oh.
81, E.
Oh.
82, B. 83, B. 84, C. 85, B. 86, C. 87, D. 88, C. 89, E. 90, A. 91, C. 92, B. I will leave those up there.
For 79, I got B as my answer.
I got A.
Get the other right answer.
Okay, well, let's do 79 then.
The B.
Now, in this problem, I'm just looking at this, you just have to use your properties of integrals. What is the value, okay, negative 2 to 5 of f of x dx is equal to negative 7d. The integral from 5 to 2 of f of x dx is equal to negative 4. What is the integral from negative 5 to 5 of f of x dx? Well, according to our properties of integrals, what am I putting an equal sign there for? Isn't the integral from negative 5 to 5, the integral from negative 5 to 2,
Yeah, I think so.
plus the integral from 2 to 5? Yeah? Okay, that's one of the 5 properties of integrals. Okay, what is the integral from negative 5 to 2? Well, that's negative 17. What's the integral from 2 to 5? Yeah, but Mr. Park, the thing's saying the wrong way, the limits. Well, so if you switch the limits, it negates the value. So this, if this is negative 4, what is this then? Positive 4, and your answer is negative 13. Why, are we making the mistake of switching the limits but not negating?
No.
That's one of the basic things right there. Anyway, we need to still go back to part A. You guys have your part A with you? Because remember, we only went halfway through this thing. But there are so many problems we have to discuss. I think we finished at number 14 or something. What? But then I sent it to you. Didn't I send
It's so
it?
hard to retain anymore.
He sent.
Okay, just listen then. Okay, number 15. There's just, okay, this is going back to basics right here. Right here. So many people got this problem wrong, and there's just no way that you should get this wrong.
Substitution.
Yes, when you do an integral, either it's on the list or you do a u substitution. Is this on the list? No, so you do a u substitution. U equal x squared minus 4. du is 2x dx. What do I substitute for that? U. What do I substitute for x dx? Du over 2. Throw the constant on the outside. Now is that on the list?
Yes.
Yes, what is it? Arakawa.
Ln absolute.
There you go. 1/2 natural log, absolute value of u plus c, and then all you have to do is resubstitute back in and pick up the answer. Now, what's another way to, like some of you go, Mr. Park, I never got u substitution. Can you still get the problem? Yeah, how about take the derivative of each of these 5 answers and see if you get that, right? I mean, it takes a little longer, but you still can get the answer, right?
Travis thinks tabular is a solution.
No, I did it. No, I did it. Mr. Clark.
I don't want to even
Clark
hear
is
the
raving. What's that?
I'm so sorry that I actually taught you guys.
Yeah, what's that?
You know, next year I might have to just take it out of the
Yeah.
curriculum.
It's a cool
But then
method.
every year before that, we put it in, they never had the problem.
Tabular is just so fun, that's why.
Yeah, you guys
That's
are.
why you-
Tabular.
When you breathe.
You know what?
It's based on the paper.
When the AP scores come back in July and I see 90%
All 5s.
fives, that's gonna be my
Oh,
greatest moment.
100%.
of my life. Even better than even my marriage or
The birth of your children.
No, I'm
Make him
serious.
proud. Let's make him proud.
You know how hard you guys don't even know how hard I'm working. I can't even sleep at night.
It's okay, you got it.
Are you
Don't
serious?
worry about it.
How is it not stressful?
We'll clutch up.
It's easy.
Yeah.
The
Pretty
worst
much.
year you've had.
Little girl Yes. has-
No, but it doesn't matter. It matters how it ends when I see the
There's
results.
Not how you drive, it's how you arrive.
Maybe just Kalani will.
Okay, here we go. So many people got this problem wrong. Okay, this is another basic. If it is difficult or impossible to solve for y,
Oh, yeah, I
like
got
in
that
this
one.
problem
This
here,
thing was hard.
how do I take the derivative? Implicit
Partial
differentiation. Not
differentiation.
Implicit differentiation. Now, how do you do implicit differentiation? You just take the derivative term by term on both sides of the equation. That's all you do. But just remember, when you take the derivative of x, you get 1. When you take the derivative of y, you get dy dx or y prime. Not y dot. No, not y dot. Y prime. Y dot is reserved for this. dy dt. When you take the derivative with respect to time, then it's y dot. But when you take the derivative with respect to the independent variable, it's y prime.
Okay.
But see, this is a multiple choice. If you
It's all
did
the
that,
same.
it wouldn't matter. As long as, but just remember, when you take the derivative of x, it's not x dot, it's 1.
Of course.
You guys understand? That's the basics when you do implicit differentiation. So here, this is what I see. Sine box. So what's the derivative of sine box?
Cosine box.
Cosine box times the derivative of box, but I see a product there,
Oh
so
my
you gotta
goodness.
use the
Oh,
product rule.
that's so hard.
No, wedging, product rule in that, go.
Absolutely
X.
exhausting.
Gotta be different.
Why?
Derivative of the first.
No, he wants to leave the first, he wants to leave the first one alone first, because he wants to be different. He wants to be a rebel. Okay, go,
I should have
continue.
brought
Y
shorts.
prime.
Y prime,
Plus, they don't have scissors.
very good. I prefer keep it
Doesn't
equals,
matter.
and what's the derivative of the right side? So
One.
1.
Sorry, stole your thunder, buddy.
Very good. How come it's not x prime? Because I just told you, the derivative of x is 1, but the derivative of y is y prime. That's what you need to do in implicit differentiation. Oh, by the way, this is going to be one of the 6 free response questions too.
Whenever.
You got it? Plus obviously you're gonna have to do it right here, right? Okay, now, what's the next step? You need to solve for y, Tsunami. I called your name 2 times.
One was calling him though.
Just for that, when me and my wife come to the, are you playing in the concert this Saturday? We're gonna be sitting there, I'm gonna be pointing, that's the guy. That's the guy I told you about. So how do you solve for y prime? You gotta distribute, you gotta multiply out everything. So x, y, now it's just algebra. All you have to do is algebra, which is a problem still.
This time's gonna take like 4 days.
And then what do? Put all the y primes on one side. So there's only one term with y prime right here. Leave it on the left, throw everything else on the right. And then finally, all you have to do is divide by the coefficient. So,
Mr. Park, can I make a confession?
okay, what is it?
I forgot that y prime was equivalent to dy over dx.
See, that's why we gotta go back to basics. For real.
Yeah. That's why when it said dy over dx, I was like,
What is that?
no.
Well,
I was
there are
like, how do you
different
find
symbols for the
of it?
derivative. There are like many different symbols for the derivative. They're gonna give you all,
I'll
just
admit
like,
I kind of
just
forgot
like
what-
arc sine. Some years they use arc sine, but then some years they use sine inverse.
See, but what's weird
Oh,
is
you better know that they're the same thing.
I always knew that f prime of x is the derivative, so I guess I should.
Yeah, 1 prime is the first derivative, 2 primes is the second derivative. Right?
Okay.
But then second derivative can be written like this too.
F2.
That's
Yeah, I remember that one.
Leibniz's notation for the derivative. So
Damn it, Leibniz.
you gotta be ready. Hey, if you have different inventors of calculus, you can expect different notations, right?
I feel like we should have standardized it by this day and age. 2017.
Unfortunately, it's not.
Damn it.
Okay, number 19. Did we do number 18?
Leibniz.
No, we didn't do it.
Okay, let's do number 18.
I got 18 wrong.
Okay, now let me show you. If you draw a picture, so like a lot of you, it looks like you guys are stuck, but then you guys don't even draw pictures. No, you have a parabola. Y equal x squared plus 3x plus 1. And the tangent line is x plus y equal k. Here's the tangent line. X plus y equal k. By the way, what's the slope of this tangent line right here? What's the slope?
1!
No, look, how can it be 1? It's going down here. Thank you, it's -1. How do you know it's negative?
I was close.
Because if you put the x on that side, you're gonna get y equal negative x plus k, right? Isn't m the slope?
Sure, why
Negative
not?
1. Okay, anyway, the key to this problem, they want you to find the value of k. Among, you need to listen.
I am sorry.
We need to compute the coordinates of this point to answer the problem. See, normally they tell you the point, but now, see, you have to find the point.
Yeah, but
Well,
I don't know how to do that.
We know the slope of the tangent line is -1, and what tells you the slope of the tangent
Oh,
line?
the first
The
derivative.
derivative, so we need to find the derivative.
Oh.
What's the come on, this is a calculus test, people. You can take derivatives and
That's
do
actually really
integrals.
smart,
That's what
though.
you do on a calculus test. So what's the derivative of this?
2x.
plus 3. that tells you the slope of the tangent line. But we already know what the slope of the tangent line is, it's -1. So we wanna know, when is this equal to -1?
X equals 2.
What value of x will give you a slope of -1? Well, if you solve this equation, you get 2x equals -4, x equals -2. Oh, so the x coordinate of this point is -2. How do I find the y coordinate? You plug it back in. So if I plug -2 back in, you get y equal 4 minus 6 plus 1, which is -1. Now can I find the value of k? Because notice that this point lies on both the parabola and the tangent line, so that means you can plug that point into either equation. So if I plug in -2 for x and -1 for y, what does k come out?
-3.
-3. But see, look, you draw a picture, it makes the problem so much easier.
Wow, that's really smart.
Number 19. A lot of people got this wrong. Now, how do you find horizontal asymptotes? Can I use the rule that I have on the cheat sheet, like if the degree at the top and the bottom are the same, you look at the coefficients?
No.
No, you can only do that when you have a polynomial over polynomial, and we don't have that here. So how do you find horizontal asymptotes?
Limit.
You have to take the limit as x approaches infinity, because as the graph is going out to the right, it might get closer and closer to something. And you have to take the limit as x approaches -infinity.
Oh.
Because remember, when do horizontal asymptotes take effect? Remember this? Up here! As x approaches infinity or -infinity. So here, let's do the, what happens as x approaches infinity? What happens when you plug in a really huge number for x? You get 2 to the million plus 5. Now, can you see that 5 is insignificant compared to 2 to the million power? So and then this one too, 2 to the million power. This one here doesn't even, it's insignificant, it doesn't even count. So basically, you just got that. So what happens if you have 2 to the million over -2 to the million?
-1.
That's close to -1. So your first horizontal asymptote is y equal -1. So we can already narrow it down. It's either A, D, or E. Now, how do you find the other horizontal asymptote? You take the limit as x approaches -infinity. Now, what happens when you plug in a super huge negative number, like -million? What happens to this? What is 2 to the -1,000,000 power? That's like 1 over 2 to the million. That's very close to 0. So this goes to 0, and that gets is very close to 0. So what's left? What's 5 plus 0 over 1 minus 0? 5. It's very close to 5. So the other horizontal asymptote is y equal 5. That's how you find horizontal asymptotes. You take the limit as x approaches infinity and -infinity.
Dude, they got me.
Okay, we need to, do we need to do number 21? See, you know when I'm going through, when I corrected this the other day, like number 20 for example, I'm not even seeing number lines. Anytime they ask you for max, min, point of inflection, there should be number lines. Like number 20, this is how easy number 20 is. I hope you guys didn't miss it. How do you find points of inflection? You take the second derivative and make a number line. Well, they gave you the second derivative, so all you have to do is make a number line. What do I put on this number line? 0, 3, 6, and then plus, minus, plus, plus. How come it didn't plug this apart? Because you get even power.
I was wondering that.
And then what does this mean? If the second derivative is positive, f is concave up, concave up, concave down, concave up. So where do you have points of inflection? At 3 and 6. How come 0 is not a point of inflection? Because it didn't change the cavity there. But I'm not even seeing number lines. It's like, you know people, anytime they ask you max, min, point of inflection, you just make the number line, it solves the problem.
I did.
Okay, I want to go over number, we don't have time to go over all of them, because we gotta go back to basics here. 23, there's just, almost everybody got this problem.
What is this?
dy dx equals, okay, anyway, this is one of the basics that we're gonna go over anyway. How do you solve differential equations where you got both x's and y's here? You separate the variables. The first step is to separate the variables. So put the y on the left, put all the y's on the left, put all the x's on the right. Anyway, if this were a free response problem, this is gonna be worth 6 points. You just got 1 point just for doing that.
Nice.
What's the next step? Integrate both sides. Okay, now these are easy. 1/2 y squared plus c equals 1/3 x cubed plus c. What do I do with the 2 plus c's?
It equals negative
You
2.
mush them together into 1 plus c on the right. That's what we normally do, right? Now, did they give me information to figure out what c is? Yup. It says y of 3 equals -2. That means if I plug in 3 for x, y will be -2. So do it. Plug in -2 there. 2. Plug in 3 there. 9. Therefore, c is -7. So this is what we got so far. Now, a lot of people got this far, and then they made a fatal error right at the end.
What did they do?
Wait, let's just finish. How do I get rid of this 1/2? Because now you gotta solve for y. How do I get rid of this 1/2? Multiply both sides by 2, so you get 2/3 x cubed minus 14. And then the last step is to square root both sides. So y equals what? No, plus or minus the square root of 2/3 x cubed minus 14. Now, for those of you who didn't put the plus or minus, I bet you guys picked D as your answer.
I did.
But the answer is E.
I also picked D.
I got Duke.
Yeah, I know. So it's plus or minus. But Mr. Park, how do you know which one it is? You gotta look at your initial condition. If you plug in 3,
Oh my
you gotta get
goodness.
-2. How can you get, look, if you took the positive one, how you gonna get a negative answer if you plug in a number?
You can't.
Cannot.
No.
That's why the answer is E.
I got Duke. No.
Okay, you got duped now, don't get duped again.
I'm
out.
out. American Duke.
Only one
What
time.
is wrong with those people?
Shame on you.
Okay, here is another basic problem. Number 25. A lot of people got this wrong. In fact, the last page, we got all kinds of problems. Now, I guarantee this problem is on every single year. It's free response, multiple choice. I gave you this problem over the year, I would say about 5 times.
Did it for you.
Okay, they're telling you that this function is differentiable at x equal 2. Find the value of c plus d. Now, what does differentiable mean?
They're equal.
Smooth and continuous. Now, in order for the function to be continuous, what has to happen? If I plug in 2 for x here and 2 for x there, you gotta get the same number so they actually touch to make it continuous,
Also-
right? So plug in 2 for x here, what do you get? 2c plus d, and then plug in 2 here, you get 4 minus 2c. That has to be one condition. But then, not only does it have to be continuous, it has to be smooth. Now, how do you make a graph smooth at a point?
The slopes.
The left-hand slope and the right-hand slope gotta be the same so that you don't have a sharp point. Because if there's a sharp point there, it's not differentiable, right? So, how do you compute slopes? Derivative. So you take the derivative of this. Now, of course, if it's a piecewise function, the derivative will be in pieces too. What's the derivative of this? C. What's the derivative of that? 2x minus c. So, when x equals 2, if I plug in 2 for x here and 2 for x there, you have to have the same slope, otherwise it's not going to be smooth. You guys get it? The left-hand slope and the right-hand slope got to be the same. So what happens when you plug in 2 for x? Well, there's no x there, so it's just c. What happens when you plug in 2 for x there?
4
You
minus
get
x.
4 minus c. All you gotta do now, you got 2 equations, 2 variables, use your algebra 1.
C is
But then you really don't have to, because right here, 2c is 4, c is 2, plug it in there, you can figure out d and you can answer the question, right? But you gotta start by writing those equations. Anyway, this was on the first multiple choice too, and then it's gonna be on every test. Certain problems are there every year. This is one of them.
So it's improvement.
Okay, number 27, a lot of people miss the slope. I thought we were experts at this already. Just plug in numbers, enough points, so that you can pick out which differential equation.
I like doing the flat ones first.
Okay, right? Are you guys plugging in numbers? Because we're getting the wrong and getting the wrong. There's no way we should get the problem wrong. Like, for example, what did Pac do one time? Pac, you did something, right?
She looked at the biggest one.
Like you plugged in 5, 5, right?
Yeah.
With upper right hand. Did that work in this problem?
What?
Not really. Not in this problem, yeah. So what I would do is I would pick a point in the first quadrant, then I would pick a point in the second quadrant, then the third and the fourth. I'll keep doing that until I figure out which one is the answer. Number 28, hardly anybody got this one. Now, this problem was on the last multiple choice. I think we ran out of time. It's on this one, and it's pretty much on every one. You gotta know how to do it. So here. In fact, when we did it during the year, I prepped you for the test. Oh, I think almost everybody got it. That's good. So that means you're capable. If you have a function and it's inverse, okay, I'm just drawing a picture, okay? Okay, so let's say, here's a point. Let's say this point is 2, 1. What would be the corresponding point on the inverse? 1, 2. Everybody agree? Because that's how you get the inverse, by switching the x's and y's. Is there a relationship between the slope of the tangent line there and the slope of the tangent line there? Yes, there's a relation. And what is it? Like, for example, if this slope is 2/3, what would this one be? It would be 3/2. They're reciprocals of each other. Now, there were a couple people in this class, they wrote down a formula that I never taught, because they said they looked it up on Google.
I wrote down nothing.
Who was it? Sonata? Takata?
I also wrote down nothing.
And that's fine. If you don't use it, I
write
didn't
down
teach it that way. It's not on the cheat sheet, Sonata. Just look, just listen to what I'm saying here, and you can do every single problem. The key is you have to know that these slopes are reciprocals of each other. So, in this problem, they give you two functions, f and g.
Genius.
Okay? This is what they're asking. What is the value of g prime of 3? That means, what is the slope of the tangent line when x is 3 on the g function? So here's the g function. When the x coordinate is 3, our job is to find the slope. If I can find that slope, that's the answer. But they don't tell it to you. They just tell you, oh, f is the inverse of g. So your goal is, if I can just find the slope here, this slope is the reciprocal of that.
Yeah, baby.
Okay, so how do you do that? Well, if this is the point on the g function, what's the point on the f function?
3, right?
Something, 3, right? This is 3 something, this one's something 3, because you switch the x's and y. Now, look at the information they gave you. I'm going to call on somebody here. Among. On the f function, when the y coordinate is 3, what is the x coordinate? It's right there in the information.
Wait, you mean when the x coordinate is 3?
No, when the y coordinate
Oh,
is
it's
3.
15?
When the y
Yeah,
coordinate
see?
is 3.
That's what I was thinking.
Look,
Oh,
if
6.
f-
6.
too late.
6.
If f of 3 is 5, doesn't that mean the point 3 doesn't that mean the point 3?
Yeah, that's why.
See, look at this class. We don't, when f of 3 is 5 means x
I
is
was
3, y is
reasoning
5.
through
That's
it.
why this class goes, oh, slope, x minus x over y minus y. I don't want to mention names to God.
I was trying to talk them through it. I was like, it
Okay,
can't be.
start all over, start all over.
I was like, it
When
can't
the
be f of
y
x.
coordinate is 3, what is the x coordinate?
6.
6, very good. And then, when the x coordinate is 6, what is the slope?
2. Negative.
Wait, Watase. Look at the, very good, -2, because it says f prime of 6 is -2. So therefore, Kai, what is the slope on the inverse then? -½ It's simply the reciprocal of that number. Anyway, for those of you who looked it up on Google, wasn't it an answer like 1
I didn't
over...
look it up. Don't look at me.
Okay, Sonata, wasn't it like 1?
You didn't look it up.
Somebody, somebody wrote it on the paper.
Right here.
Look at that.
I didn't-
Right
Look at that. I did it all in my head, so can't.
I did it all in my head. Did you write
Does
how?
everybody understand this problem? Because
You wrote
it's
how
gonna
on
be
my
on-
paper?
It was on the
Put it
first
down.
one, it's on the second one.
You just look at it, bro.
Nakama?
Whoa.
Just look at it.
Yeah. Okay, now we're going to part B.
Sometimes
I want to slap all the hair off.
Yeah, that's coming up.
You'll never get on my hair.
What time does this class start?
Cheek hair is too strong.
Oh gosh. Okay, we're supposed to be out of this already, but that's okay. These are.
I learned
the
big things
yes.
today.
I learned everything today.
Okay, we're on part B of
Yeah.
81.
I forgot about the camera.
Hey,
Is it going?
Yeah.
Yes.
Oh, hello.
then don't say bad words.
I
God.
can't see it.
She's not in Takata. Saying all the
Oh, I
bad
can't
things.
see you, Wheeler.
Who the hell's Sonata?
Pretty sure Sonata said I hate you.
No. Okay. Shh. Hey, we're wasting time here. Okay, we're on 81. Look, this is the kind of problem that'll typically give you trouble right here. This is cold red right here.
I recognized it.
Capital G of x is the antiderivative for f of x. If capital G of 2 is negative 7, what is capital G of 4? Okay, so what am I going to do? See, again, if they give you a function and they ask you to compute something about its antiderivative, that's when you use code red. So I am going to integrate f of x. What limits do I put on here, Kojima? What limits should I put on here? From where to where?
What are we doing?
2 to 4. Why 2 and 4? Because one of them is given and the other one is not.
Obvious.
So, how do you compute an integral? You find the antiderivative of this, which they told you is capital G, right? Plug in the top number, plug in the bottom number, and subtract. Now, this is what we're trying to find. They told you that this is negative 7. That means, well, what are we trying to find? G of 4. Oh, we can't compute this, so all you gotta do is...
Yeah, you just move it over
Yeah,
and
just
you're
move it
done.
over. So, G of 4 is equal to this integral minus 7 or plus 7?
Minus 7. Because the negatives.
And is the answer there?
You're
There
gosh
you
darn
go.
right
It
it
is
is.
right there. Cold red.
You bet your sweet little baby. Hey, did we do 80? Or should I just know 80? I got it wrong.
Okay. No, let's do number 80. Let's do number 80. Okay, they give you the first derivative. X is x squared cosine x squared. How many, this is a good question to ask. How many points of inflection does the graph have from negative 2 to 2? Now, how do you find points of inflection?
Second.
You take the second derivative and you make a number line. Okay, now there's two ways to do this. One is to actually compute the second derivative. Now, I see a product, so I'm going to use the product rule. So how's the product rule? Derivative of the first, leave the second one alone, unless you're uechi. Leave the first one alone, derivative of the second. That's negative sign box times the derivative of box. Graph that on your calculator, and all you have to do is between negative 2 and 2, so this is what you look for on your calculator. How many times it crosses the x-axis? Because every time it crosses the x-axis, that's a point of inflection, right? Because the second derivative changed from positive to negative. From negative to positive.
And you just.
Now, Mr. Park, that's kind of messy to do the product rule. Is there a way that I can just tell the calculator, just graph the derivative of this? Yes, we just talked about this last week. Just tell your calculator, do this. Graph the derivative of, I think it's a parentheses, x squared cosine x squared slash x equals box. What do I have to put in the box? Yeah, just put an x there, and your calculator will graph the derivative of that, what you have there. You don't need to use the product rule.
So you're already in the ground area.
But to me, either way, because come on, that's an easy product rule. That's not like a challenging product rule.
X equals.
How do
Okay.
you get the derivative in this part?
Options, calculus, right?
Oh.
Yeah, options.
Wait, what do we put in the little x equals box?
X.
What is
Because
that?
you want your calculator to compute the derivative at every value of x and then graph it.
Yeah, so if we already have a value of x stored in, because the.
No, it doesn't matter. No, don't worry.
What?
Just put x.
Wait, here.
Just
Come
put
up.
x.
Come up.
Yeah, wait, is there something wrong here?
Are you in radian mode?
Yes.
There's something wrong here. Let me see. At x equals x. I think you need to put the parentheses. This is what I think. You didn't put the parentheses over here. That's what I think.
Yeah, that sounds good.
Where?
Because I'm not sure what the order of operations. I don't know. I mean, I know what the order of operations are, but sometimes
It's the same.
calculators can do bad things.
This part is the same.
And then what's happening?
It just comes out as a number instead of.
You mean you're just getting a horizontal line? No! No!
What?
No! You're graphing this on your calculator, Sonata. Y1 equals this.
I was wondering what he was talking.
Of course. See, Sonata's just doing this. You're supposed to
Sonata!
graph it.
I wasn't even here, but what an idiot!
What is your problem?
How many times?
I didn't do anything.
It's like
I'm the best.
on the regular like.
Not idiot.
Windows.
1, 2, 3, 4.
So I just do this the same
What
thing
about
on
here?
the ground.
What a foolish man.
Oh.
Damn it!
Yeah,
Who was doing it just in the
I know, that's so stupid. I don't know why.
Oh, okay, there's another mistake. If you don't graph it from -2 to 2, maybe you don't see all the times it crosses the x-axis. So make sure you
Yeah, wait,
set the
see, I only saw 3.
89. Okay, we got time for only 1 or 2
No,
more.
that's
We
just
gotta-
5.
Otherwise, we're gonna miss our opportunity on going over basics. Okay, now, we were gonna go over this in the basics anyway, okay, here?
Yes.
We have a function, a continuous function. So what should you do in this kind of problem when they don't give you a specific function? Draw a picture. The function is continuous from -2 to 2. F of -2 and f of 2 are both 0. Okay, so draw that. If there is no value of c where f prime of c is equal to 0, there is no place where this happens, then what can you say about which of the following statements is true? Now, what of the theorems that we've learned throughout the year where they even use f of c or f
The
prime of
mean
c?
value
Either the mean value theorem or the intermediate value theorem, right? Now, what does the mean value theorem say? In fact, you just had a speed quiz on the yesterday,
I
right?
forget.
There, if you have a differentiable function from a to b, there's at least one place, somewhere in between a and b, where f prime of c is equal to f of b minus f of a all over b minus a. They are testing you to see if you understand the mean value theorem in this problem. Now, so in this problem, what is b and a? What is b and a?
2 and -2.
-2 and 2. So this is 2, this is -2, this is 2, -2. And what does that come out to?
1.
What is 2?
4.
Wait,
One.
f of b. Wait, what is b? Oh, they're both 0, that's why. 0 minus 0 over 4, which is 0, right? So the mean value theorem says if this function is differentiable, there's at least one place where the slope is going to be 0. That's what the mean value theorem says. However, in this problem, it says there is no value of c. Well, what can you conclude from that? This function is
Not differentiable.
not differentiable. Can you pick out the answer?
Yes.
Which one is it? E. Yeah, because there's somewhere in there the derivative is not going to exist, and there's going to be a sharp point or something.
Oh my.
Yeah. So you have to understand the mean value theorem applies to differentiable functions. If it's not differentiable, okay, we got time for one more. Let's look on the back page. Okay, if we miss number 91, I should charge you guys money. Average value. What's the formula for average value?
1 over b minus
1
a.
over b minus a, integral from a to b of f of x dx. Punch that in your calculator, get the answer. That's
What's
an
this?
easy.
What do you do 90?
Okay, let's do 9. Now 92, okay, we're gonna have to table 92 because we gotta, look at the time. We gotta go back to basics here. Number 90, f is continuous from 2 to 4 and twice differentiable if f prime of 3 is equal to 2 and f double prime of x is less than, what does this mean? The second derivative is less than 0.
Down.
It's concave down. Which of the following could be a table for the values of f? Okay, so this is what I would do. F prime of 3 is 2. That means the slope at 3 is 2. But see, they don't give you a specific function. So like, let's just look at the A table. Just the A table only. I'm just going to tell you what to do and then you try to do it again. Plus you guys have the answer. How do you, okay, let me ask you this. How do you find the slope between these 2 points?
5 minus.
Y minus y over x minus x. So this minus that, 2.5 over 1.